Hey guys, so in this video, we're going to start talking about exponential growth and decay functions. It's going to be 3 parts. So you'll have 3 different videos, each video focusing on a different aspect of growth and decay functions. So today's first one is going to be on what they are and how to graph them. So there's a bunch of do now stuff we're going to talk about in class. So I'm going to start with, well, what is a growth and decay function? So exponential functions are in the format you see here. Y equals a times b to the x plus k, okay? So your a is your initial value, b is your base, x is your exponent, which is why it's an exponential function, because your input is now in an exponent spot. And then k is your vertical shift, and that's where our asymptotes are going to come from. Just so you're aware, domain and ranges we're going to be talking about. Domain is always all real numbers. I can put any number I want in for x. I have no restrictions. I'll always find a y. Okay. The range, however, does have a restriction. And you're going to see, or you did see in the do now, that it kind of stops. It has this boundary line here, and we call that an asymptote. So for the most part, your range is always going to be greater than your k value, whatever the asymptote is at the end. If your graph happens to be flipped, if it's a reflection and it's going downward in an opposite direction, then it would be less than k because everything's underneath it. But for the most part, all of our values are going to be greater than k. Okay. So we're going to start with talking about what's growth, what's decay, and how do you know that? So a growth function is when your base is bigger than 1. I think of it as if it's bigger than 1, it's growing. It's getting bigger and bigger and bigger, right? So your growth function starts low. You can see it's kind of riding along the x-axis, and then it shoots up really high. It grows really fast. So we have this growth function, domain's all real numbers. For your parent function, which you see here, the range is greater than 0. You can see it's riding along that x-axis. Rises from left to right. You're going to see it passes through 0, 1 in this case, and the point 1b. 1b is very important because it gets you your base. Remember, anything to the first power, so if I put an x as 1, anything to the first power is itself. So the base is always your y value when x is 1. Okay, so that's going to be really important to know as we go through this. I'm going to skip ahead a few of these. Okay, here we go. Into our decay. Okay, so your decay is kind of the opposite. It starts really high and then goes really low really fast. Okay, so a decay function is when your base is less than 1. We say it's between 0 and 1 because it's not going to be negative. You can't have a negative base, but you will have between 0 and 1. So a fraction or a decimal that's less than 1 means it's a decay. Again, domain's all real numbers. Again, the range is greater than 0. It's still above the x-axis. But again, I can see it starts really high, shoots down really fast, gets smaller and smaller and smaller. It decays. All right. Again, it goes through the point 0, 1. Also 1b. Again, whatever your base is, anything to the first power is your base. Now, if they don't have the points labeled on a graph, we're going to see some of this in the first examples I talk about with you. 1b is going to be hard to find, especially if it's a decimal or a fraction, because you don't know exactly what those decimals or fractions are. So we can also use the reciprocal of the y value when x is negative 1. Remember, if I put a negative exponent in, it flips its position. Okay, so if I had negative 1 comma 2, the base is 1/2. If I have negative 1 comma 5, it's 1/5. Okay, and we'll see that in the examples I'm going to talk about with you. So I'm going to skip these and go straight to this. So I'm going to talk about the first and the last, just to save time, since we're going to be doing them in class anyway. So looking at these, I can see it starts low, goes high. So this is a growth. I can see the points negative 1/2, 0, 1, 1, 2. I can see it's not crossing the x-axis. It gets really close over here. So 0 is my asymptote. So that would be my k, right? So if we go back and think about our growth functions, well, any of our exponential functions really are in this format. A, initial value. B, your base, to the x. Oops. plus k. All right, so a is 1, it's my initial value. B, remember, comes from the point 1 comma b, so b is 2, and k is your 0. All right, so again, there's your a. B is 2, bigger than 1, so it definitely goes with my growth. And when I put it all together, y equals 1 times 2 to the x plus 0, but we don't tend to write it like that. It would more look like this, y equals 2 to the x. All right, and that's how you would do it for each of these. If I look at the last one, it starts really high and goes really low. This is a decay function. Okay, it's getting smaller as it's going on. I can see the points that it's going through. There's my A, there's my B. Asymptote gets really close, doesn't touch. So that's your K is 0. And again, if you didn't have this point 1 comma 1/3 blocked off, I could use this, knowing that -1 is 1 over B. It's reciprocal. So 1/3 gets me the same number, okay? Okay, base is 1/3, less than 1, smaller, decay, perfect. And this would just be 1/3 to the x power. Yeah, I don't have to write the 1 and the plus 0 unless you really want to. Notice I kept the parentheses around the fraction here. You could put it around the fraction, or sorry, around the 2 in this one and have it 2 to the x. That's fine. I tend to just keep it with your fractions and decimals, just so you make sure that the exponent is with the whole entire fraction or decimal. Okay, so again, we'll go through the rest of those in class, but importance of knowing what is your k, what's your asymptote, where's your starting point, or your y-intercept, what is your b value. Okay, so let's graph some of these. Let's do, we'll do 4 and 5. Again, we'll be doing most of these in class. So number 4, before I even start, I'm going to do my domain and range. I have A, B, and a K. So I can put plus 0 if I want. A is 1. All right, I know that. B is 1.5, I'm sorry. So this is a growth. It's bigger than 1. So I know my graph is going to be going in this upward motion. Domain, all real numbers, always. Your range is y is greater than your k value. Well, k is 0. So y is greater than 0 would be your range. So you could find domain and range without even doing anything with your graphing. The way we're going to graph is to create a table, -2 to +2, and then we can plot the points. Now we're going to use Desmos to help us with that. So let me get out of this real quick to show you. So in Desmos, we're going to use a table feature. You hit plus, table. You're going to make x just x. So get rid of that sub 1. We're going to take, y sub 1, take it out, and put in the function. And the function was 1.5 to the x power. Okay, we're going to go from -2 to +2. Right, and again, from here, we can see our values. You can even see the graph showing up there. So it's nice, but if you do have to do it by hand, you need to know how to graph it by hand. So we're going to talk about that. If this is just a draw graph, you can screenshot that. I'm okay with it. But if it says draw by hand, make sure you draw it by hand. So let's go back, present this. We're going to write our table down. Okay. Okay, so it was 0.44 repeated, 0.66 repeated, 1.5, and 2.25. Okay, so we're going to put this on our graph. I'm going to start with the little easier ones to do. 2.25. So here's 1, 2.25, a little over 2. 1.5 is halfway. 1 we know is here. 0.6 is 2/3 of the way up, and then it gets smaller and smaller. And I can see clearly where my graph is going, and I'm going to connect those dots. And there's my graph. Okay, just be careful when you trace and you connect the dots. Don't just throw them off into the, throw it off into the left and throw it off into the right. Make sure it's going in the order it should be growing in. All right, so don't just, keep going out this way. Don't curve it in the wrong direction, basically is what I'm getting at. All right, let's do one more. We'll talk about this last one here. So 1/3 x plus 2. So this time I do have a k value here. All right, so again, domain, we know is all real numbers. This time my range, y is greater than k, there's my k value. So y is greater than 2. So I'm going to have this asymptote at a positive 2 here, meaning it's never going to cross that line. So everything I do is going to be above that 2. So keep that in mind as you go through and graph this. Okay, so same thing. I'm going to go on Desmos. Okay, so I'm just going to clear out this one and type in the new equation. So it was 1/3 to the x. Okay. So here I can see, right, I got 11, 5, 3, 2.3 repeated, and 2.1 repeated. It's not crossing 2. I can clearly see that. It's getting really close, but it's not crossing it. That's my asymptote. So again, I can go back here and we can set up our table. Okay, so it was 11, 5, 3, 2.5, and 2.1. So again, here's my asymptote. It's not going to cross it. Now, negative 211, that's up here. Now, if it was way off my graph, I might not have fit it, and that's okay. Just draw the ones that do fit. So -1, 5, 2, 3, 4, 5, 0, 3, 2.5, 2.3. And again, when I connect this, I want to make sure I connect it going in the motion of the graph and not going below the 2. Let's talk real quick about this y-intercept at 3, though, right? Because we said it's usually our a value. A is 1. Remember, it's 1 plus a 2. So your y-intercept, I do have to include the fact that I have this asymptote that's raising it up by 2. And 1 plus 2 gets you 3. All right. So hopefully that helps. We'll go through more of the examples in class. If you have any questions, make sure you reach out and ask.